What's up? It's your man, Jimmy Chan. All right, so today we're going to be talking about using the hypothesis test, but on a population proportion. So I figured that I would just use an example and then go through the steps with you guys. All right, so let's take a look at this. So Humira is a medication used to treat rheumatoid arthritis. In a clinical trial of Humira, 705 subjects diagnosed with RA were administered 40 milligrams of Humira every other week. Of those 705, 66 reported nausea as a side effect. It is known that the proportion, remember the proportion of RA subjects in similar studies receive a placebo who reported nausea as a side effect is 0.8. Again, proportion. Does the sample evidence represent significant evidence or significant evidence that a higher proportion of subjects receiving Humira experience nausea as a side effect than taking those taking the placebo? Use an alpha of 0.05 level of significance. Okay, so there are some key parts right there for me. All right, so in this case, the first thing is to write our null and our alternative hypothesis, right? Because I see the word higher proportion, that means I'm going to be doing a right tail test, right? So if it was no difference, if it was less, or decrease or whatever, right, would be left tail. And if it's higher, greater, increase, then it would be a right tail test. So in my case here, because of the higher, I would say my null hypothesis is that my P is going to equal to 0.08, because that's what we found. And my alternative hypothesis is going to be that P is greater than 0.08 because I saw the word higher. Okay, so there I go. I wrote the alternative hypothesis. Next, I need to check to see from a simple random sample to check to make sure that N times P times 1 minus P is greater than or equal to 10. Okay, so what is my N? Well, I have 705 subjects. So my N, here, let me do this. So this is my N. Okay, actually, this is my N. What will be the 66? That's going to be my X. Okay. All right. So let's do this. So N, 705, times my P, which is 0.08, times 1 minus 0.08, and see if that's greater than or equal to 10. And if you do the math, it is definitely greater than or equal to 10. It's around like 51 point something. All right, so the math checks out. It does work. Uh-oh. There we go. Okay, so there it is. All right, so that's step 2. Step 3, find the z-score. Okay, now what's the difference between z-stat and z-critical? Okay, z-stat is based on our statistics, what is our z-value? And the z-critical would be, hey, what is our level of significance, right? So this right here, okay, I can use the rectangle. This right here is going to say, because my alpha was equal to 0.05, right? and it's one tail, so that means everything is there on the right tail. Okay, so if that's the case, then what I want to do is find the z of 0.05. That would be my z critical. Z statistic would be what do I get as a z value when I type the statistics in. Okay, and of course you can find the z of 0.05 by using on the TI. Remember, you had the inverse norm. Of 1 minus 0.05 comma 0 comma 1. Okay, let's see here. That's right above. Minus 0.05 comma 0 comma 1. And that you will get a 1.645. Okay, so this would be my z critical. Okay, for the z statistic, this is where I need to actually solve for it. So let's do that in blue. So z statistic here, let's take a look. Let's pretend that this line right here is my z statistic. Okay, so if I take this line and I move it around, so if I'm in this tan area, I'm good. The problem is that once I move into this region here, where you see all of this blue right here, anytime my z goes into this blue, I'm going to drown, all right? If I'm on the sand, I'm good. If I'm in the water, I'm drowning. Same thing if it's left tail. In the sand, I'm good. In the water, I drowned. In two tail, same thing. If I'm in the sand, I'm good. On this side, I drowned. On that side, I drowned. Okay? So that is how the left tail, right tail thing works, or the two tail thing works. That's when we know to reject or not. So again, do not reject the null, reject the null, reject the null, because I'm in the water. Reject the null because I'm in the water. Don't reject the null. I'm good. Don't reject the null. Reject the null hypothesis. Okay? So that's how we would go about doing it if you want to look at it that way, rather than remembering something like this. Okay? So if you're safe and on the sand, getting a nice tan, you do not reject the null hypothesis. If you're in the water drowning, reject it all you want. Okay? So, with that being said, let's find the z statistic and compare it, right? So we already got the z critical, right? So z critical, I'll put it right here, which is 0.05, is equal to 1.645. Meaning, if I was to throw this on here, I know that 1.645 is somewhere here. Okay, this is 1.645. That means I'm all in here. Okay, so again, if I am here on this side of the red, I'm safe. I do not reject the null hypothesis. And I keep the null hypothesis. If I'm in here, I'm going to reject the null hypothesis. So bad, good, bad, good, bad, good, bad, good, bad, good, 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 bad, 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 bad. Okay? All right. So let's go ahead and find, that was in green, so let's go ahead and find our z stat. And that was a long equation, wasn't it? All right. Whew. Oh, first we got to find that. Let's find that p stat first, right? Or I'm sorry, the p hat. So p hat is equal to x minus n. X was equal to 66 divided by, was that 705? Is that what it was? 66 divided by 705. Okay. And what do we get? Do we want to leave it? Well, no, it's approximately 0.094. Okay. So from there, let's now find my z-stat, which is equal to a big thing here. It says p hat minus p naught, which is 0.094 minus 0.08, right? Because is a p right here, right? That's what's given. Divided by all of that. Okay. So I have the square root of p. So that would be what? 0.08 times 1 minus 0.08 and divided by n. Okay. So this z statistic is going to be a 1.37. Okay, where's 1.37 on this graph? Well, 1.37 would be somewhere here. So am I safe? And the answer is yes, I'm very, very, very safe, right? So if that is the case, I would just call it, I'll say this. Since z sub s is less than z critical, do not reject the null hypothesis. Okay, so if that's the case, then we're going to write it down. Okay, then we're going to write down our conclusion. And the conclusion is there is not enough or sufficient evidence at the alpha equal to 0.05 level of confidence it does say level of confidence up there, right? Oh, of significance. To conclude, the proportion of subjects taking Humira who experience nausea is greater than 0.08. Okay. So the question is, how will we use the p-value to do the same thing? Well, to find the p-value, we would be comparing the p-value of the z-stat versus the p-value of the critical. So we want to see, so essentially what we want to do is this. We will have to find the z-value anyways. And since it's a right tail, we're looking at the p-value of z critical, which, right? Which we already know this. This right here, we got the z value from that p, right? This is really the level of significance, which is alpha. So we already had that. But what we do have to find is what the p-value of z being greater than my z-stat. Okay. So, meaning the right tail, right? So in order to do that, what I have to do is I will have to do, for the TI, I will have to do the normal CDF of the 1.37, right? Because that's a z-stat. That's the minimum. That's a so-called, actually, you know what I should do? I should put this down here. That would make more sense. To find this, I would have to do, let me do it this way. Because when we wrote this down, this would be the lower bound, comma, the upper bound, comma, 0, comma 1. So we will do the normal CDF of 1.37, comma, the upper bound, which is to infinity, comma, 0, comma 1. And we should get 0.0853. Okay. For Desmos, Desmosy. All right, for Desmos, we would have to do the normal distribution of 0, comma 1. Then we'll have to check off the CDF, and the minimum would be the 1.37, and the maximum, oops, not the man, the maximum would be leaving the infinity. And you should also get the same thing. Okay? So, all this is saying is, if I was to look at this again, if I look at the level of significance here for the alpha was 0.05, right? So alpha was equal to 0.05. That represented 1.645, which is right here. And everything in red represents the 0.05, which is alpha, right? And then this right here, we saw it was over here. So if you look at this, of this area was 0.0853. So, in other words, my P of my stat, my p-value of the stat is greater than the p-value of my critical. In this case, do not reject H naught as well. So in other words, if I have enough area that can cover everything, I do not reject. I'm good. If I can't cover it, then disaster is going to come, overwhelm is going to come, okay? And of course, again, then we have to make our conclusion, which I did on the other part, right? I did write out the conclusion, and this is still my conclusion right here. No matter if I use the Z or you use the P, I'm still going to do the same kind of conclusion, okay? However, the Z is going to help me get there anyways, so the only thing that I will have to do to find a P is that I find the Z first, then I find the P, okay? But again, what did I do? So don't forget this. I have this alpha, right? So this alpha is already one of my P's. I had to convert it to Z here so I can compare it to the Z stat. So in order to, when I do the find my P, my Z for my, well, I should say my alpha is already done. I just have to find the p-value for my Z stat. So again, that depends on if it's left tail, right tail, or two-tailed. All right, so that is everything that we need. So that way we can compare, which gives me the same exact thing. Is there a chance that one is going to be different for the Z-score? It's going to tell you to reject, while the P is going to tell you to not reject? That is not going to happen. One is going to match up with the other as well. All right, if you have any questions, let me know. See you. Bye.